It's a pleasure to have everyone in this particular course today. What we're going to talk about is actually physical or environmental security domain. This is of the CSSP, which is the Certified Information System Security Professional. And we'll talk about how these items relate to the actual CSSP exam. Now, this particular presentation was created by another individual, but it was provided under the Creative Commons license. And we're actually using this presentation and another one to talk about physical security as it relates also to augmented and virtual reality to kind of enhance security training mechanisms. Now, this particular domain addresses threats, vulnerabilities, countermeasures that can be utilized to physically detect the enterprise resources and enterprise information. A lot of times when we think about cybersecurity or security in general, we forget about the actual physical securing of assets, whether it's the protecting people, the facility, other associated resources. But we forget about gun gates and guards, as we like to say in the military. Forget about those particular aspects of security. And it's important to think about those aspects. They're very important. You can have all the firewalls and routers and intrusion detection devices that you may need from a technical standpoint, but securing a facility is yet another item to think about. So here are items related to domestic events. So you had a number of them that have occurred. You had Hurricane Katrina, you had 9/11, which was the attack on the World Trade Center, Pentagon, and Shanksville, Pennsylvania. You had the Federal Office Building, Oklahoma City, back in 1995. And then you had international events with the U.S. Embassy in Kenya, Beirut Barracks in Lebanon. More recently, Boko Haram in northern Nigeria, the Arab Spring. And so you had a number of other events that have actually occurred, and all of these relate to physical security. So a lot of things to think about. And also when you think about Kenya, not just the U.S. Embassy, but also what happened in the mall in Nairobi. So there's a lot of different physical security events and leaks or issues that have occurred in the last couple years that are very relevant to today. Now, there's a number of references for physical security. These are but a few. There is the Interagency Security Committee. Basically, they have a number of items here: design basis threat, the use of physical security performance measures, which was drafted June 2009. The Department of Defense has quite a bit of stuff too. The DoD has the Unified Facility Criteria, which is the UFC 41001, which is basically the minimum anti-terrorism standards for buildings. A number of these documents are public. You can actually take a look at these. Then you have the Department of State. They have their own document as well. They have their Overseas Building Operations International Code Supplement. And then for commercial facilities, you have the Crime Prevention through Environmental Design, which is the CPTED. Additionally, you have organizations such as As Is, and As Is an excellent organization as they provide the ability for individuals to get certified as a certified protection professional. So individuals that understand physical security, they understand all of the mechanisms that need to be in place so an organization is secure from a physical standpoint. All right, so you have different categories of security controls. You have management and administrative controls. These are essentially policy standards, processes, procedures, and guidelines. So this is more of the executive level, mid-level management. Then you have physical controls. And now these are the controls that are for the facility. Locks, doors, walls, fences, curtains, etc. There's a number of different items that you can actually have. And it's important to understand the difference or the variation between all these physical security controls. There's different types of locks. You can have a biometric lock. You can have just a standard lock on a door. Fences, there's different types of fences that you may want depending upon where you're actually at, which is going to reflect light, which is going to allow you to kind of see through the fence so you can see someone coming aboard. Same thing with curtains. Maybe you just need a curtain. People think, okay, I got curtains for shades, but you may need a curtain kind of to block out items. The individuals trying to look in, through the curtains and stuff like that. So you have that, and then you have different service providers. These are you have your FSOs, security guards, FSOs, facility security officer, and so that's what the FSO is. Then you have technical controls. Basically, these are access controls, identification, authorization, confidentiality, integrity, availability, and non-repudiation. So you have CCTVs and cameras. You have IDSs, which is intrusion detection systems, moisture detection systems. You have fire and smoke detection systems. You have fire suppression, environmental control systems, UPS. This is your uninterrupted power supply. Then your service providers for this, you have a building architect, you have a critical infrastructure protection engineer or a SIP engineer, and then you also have your operations center. And so you can see here, when you just think about the broad range of category security control, there's a number of different controls that are actually in place in terms of a security aspect. And, as we talked about the other items, we talked about understanding more of the technical items earlier in this course. Now you're able to see that the security items are just as, if not as complicated as the actual technical ones, understanding how to get those items in place as well. Now you have directive controls, and basically these are the items that are intended to advise employees on the behavior that's expected of them during their interfaces with or the use of our organization information systems. Then you have preventive controls, and these are basically controls that are to preclude any actions violating policy or increasing risk to system resources. Now, another thing in terms of preventive controls or preventive security, you can think of, or deterrent, you can think of, well, deterrent is next. So let's talk about deterrent real quick. So deterrents are basically warnings, right? These are basically controls that involve the use of warnings and consequences of security violations. So for individuals that are leaking proprietary information, you may have pictures of people who have done it previously and their associated jail sentences. And so that would be kind of a deterrent, right? Or you could have a sign that says, warning, stealing information will land you X fine or years in jail. That would be a deterrent control. So that's an example of a deterrent. Now, deterrent control also, as it relates to physical security, would be I have a sign outside my house that says dog inside the yard or beyond fence or something like that, or warning, do not enter. That would serve as a deterrent. So something that gets the individual to think, okay, well, if I do this, there is a there's the ability that something negative can actually happen from me taking action, any further action. Then you have detective controls, and these are items that use the practices, processes, and tools to identify and possibly react to security violations. Then you have corrective controls, and these are basically, they involve physical, administrative, and technical measures designed to react to detection of an incident in order to reduce or eliminate the opportunity of an unwanted event to recur. Then you have recovery controls, and basically this is after an actual incident occurs that results in a compromise of integrity or availability, or the implementation of recovery controls is necessary to restore the system operation to a normal state. So this helps the operation get back to where they were prior to the actual security event actually happening. All right, so we're going to talk about the different types of threats. So you have natural, environmental. So these can be earthquakes, floods, storms, hurricanes, fires, snow, ice. I mean, think about today in St. Louis, we had, a large accumulation of snow. So a number of organizations closed for the day. That would be an example. You think about the airport. The airport had, I believe it was a tornado that came through and tore the airport up years ago. That would be an example of an actual natural or environmental disaster. Then you have man-made or political events. Basically, these are explosives. You have disgruntled employees, unauthorized access, employee errors, espionage, arson, fire, sabotage, hazardous toxic spills, chemical contamination, malicious code, vandalism and theft, and then active commission or omission. And so these are all man-made or political events. So, maybe their individuals are running for a political party, especially in developing countries, especially those that aren't as open in terms of freedom of speech and stuff like that. Maybe individuals are trying to get their point across by maybe bombing a building or setting some cars on fire or something. Maybe something happens that says, hey, that we're not entirely happy with the current state of affairs. That would be an example of a political event. And so we can even look in our own backyard and see various political events and see how has that kind of turned out. So these are other items that are threats to the physical environment. And it's important to understand how these actually threats differ from place to place. And you can look at that. You can go to the CIA webpage and you can kind of see how the political platform is in a number of other countries and see, what's going on. The CIA webpage does a great job of letting you know that. There's other websites where you can see kind of the corruption factor. You can see levels of corruption. They'll tell you, how corrupt is the country, how safe is it, what can you do, and they'll kind of give you an example of what could occur in terms of man-made or political events. I'm going to skip over here, and we're going to talk about strategic approach to physical security. And so this is the CPTD, which is crime prevention through environmental design. And so essentially what this deals with is actually deterring crime through physical and environmental design. And so here you have natural surveillance. And basically these are items that maximize the visibility of people, parking areas, and building entrances. A number of times when organizations are building new facilities, they need to think about how can they ensure that, you know, shoppers or potential employees shoppers, potential employees are actually safe at their organization. So let's think about UMSL for a minute. Let's think about our own institution. So as we go through Express Scripts Hall, you understand that near the areas, there's some items that may not be as well lit. And so from a physical security standpoint, you say, okay, I want all these items well lit. We have these trees that are nearby, so someone could get taken and brought into the trees. How do we kind of deter that particular threat? And so maybe there could be something in that tree or bushy area, maybe lights or whatever, to kind of light up just a little bit further in the event someone does get taken into the trees. And so that would be something to think about in terms of visibility of people. You know, building entrances is important, but also in terms of building entrances, also thinking, that's surveillance, of course, but in terms of security and making sure nothing happens, like someone driving a car through, that is why a lot of times you see these columns in front of the actual door. So no one's able to actually drive a vehicle through these particular stone structures to actually, you know, drive their vehicle into the actual front of a door. So territorial reinforcement, basically these are architecture features that distinguish private and public spaces, you know, fences, gates, landscape. So say if you're working, you know, you do a lot of work with the military, you notice that they always have these areas that are available for the public. And then as you continue to move further, then of course you have your deterring signs or deterrent signs. And then additionally, items change. So individuals do not know, individuals that did not know that they could not enter in a particular area, they can't enter. And so that's something else to think about. Then of course you have all right, okay. Natural access areas, so basically structure elements that discourages access to private areas. Again, this is like street signs, landscape. In terms of streets, you can have signs on the street that say private entrance. Same thing with landscape. In terms of landscape, you can just have the way that the landscape changes so they know that this isn't a commercial area, that this area is kind of prohibited. And then of course, target hardening. Basically, these are architecture elements that prohibit unauthorized access. These are door locks, windows locks, interior hinges, etc. And there's different types of all of these items that can be used in correlation to each other. All right, so defense in depth takes upon multiple views. Defense in depth is layered security. That's all it is. For those who are actually listening, the presentation is uploaded on your My Gateway. It is titled Physical Security. So if you download that, you can actually follow along. It's approximately, I believe, 60 slides, but you can follow along as well. So here, in this particular defense in depth picture, the strategic approach to physical security, what you see is you see multiple floors. And then, of course, what you see all these other items. So you see on-premises security cameras, security breach alarms. You see electronic motion sensors. You see continuous video surveillance, biometric and exit sensors. And then you also have these systematically braced racks as well. So you have a number of these items up. You also have the UPS backup generators. You have the HVAC control environment, the redundant environment in case something does go down. You have a redundant environment for the HVAC. Then you have gas-based fire suppression. And then you have the server operations, the 24/7, 365 server operations monitoring. So you have all of these items here to ensure that the building itself is secure. And you can see that there's multiple items, there's multiple layered items here, right? So there's something to protect your technical equipment. You have monitoring, you have motion detectors, you have a security breach alarm. So if someone gets through a particular area, there's an alarm that there's an alarm that goes off. And then if you look to the bottom right, you can see my mouse moving. And this is what I was talking about earlier in terms of, being able to stop an individual from entering a particular gate. So you see these columns here, and it looks like these columns actually rise. In Belgium, near some of these places that are, moving as they move diamonds around, they actually have a number of these columns that actually arise from the ground. And so here you can actually see the landscape is different. So you have the open area right here. You see the same thing in prisons where you see the open area. Then of course you see the fence, of course the barbed wire, and then you have the tall light to illuminate the dark area when it's late at night. So you see that there is a ton of different stuff to consider when you're thinking about actually defense in depth in terms of physical security. So here's yet another look. So you can take a look at this particular item here, and you can see how this item looks. All right, so here's talking about design failure. And so this is important, right? So here you have a security camera, but it's being blocked by a sign. So this camera is now a waste, right? Because it's being blocked. And here it's funny because now it's showing all these, this particular path up here to walk, but you can't really get through. See? This is a design failure as well. And here's yet another design failure where the ATM machine is too high for anyone to actually reach. So yet another design failure. So when you think about actually designing anything, whether it's technical or whether it's non-technical, you have to think about how the actual human user is going to interact with these particular systems. And you also got to think about the usability of these systems as well in terms of what is your expected use, right? So someone here in this other item where you see the camera versus the sign, this could have just been placed differently, or the sign could have been moved over to maximize what the camera can do. But now the camera is just pretty much worthless. All right, more design failures. And this is really funny because now you see the escalate here going up, but yet you have to duck to make it up there. And now you have the two urinals that are, side by side. Very uncomfortable. Now you're looking here at this design failure, and what you'll notice is actually a train track going through the back here. Yeah, we want to avoid design failure by all means possible. When we design something, we need to think about the entire process, right? We got to think about the entire process design. Now, as it relates to design process, as the IS has the system development lifecycle and stuff like that, any other whatever methodologies that may be used, or the physical security has its design process as well. So there's 5 phases, and you have the first phase, which is to discover the needs, understand, discover what's needed. You have the second phase, which is define the system requirements. What are these system requirements? Remember, we talked about that quite a bit from a requirements engineering standpoint, where you have your shalls and wills. Remember, your shalls are the items that you must meet. Those are your threshold requirements. And then you have your objective requirements, which are your wills, like I will get an A, right? So you will get an A. Doesn't mean you necessarily have to get an A, but you shall get a B or you will be put out the program. So think about that in terms of requirements. Then you have phase 3, which is design system architecture. So, design your architecture. Phase 4, develop detailed design. And then your last phase is to implement the actual design. And then you'll also know here that you have users and users representatives throughout. It's important to understand how the user is actually going to use the system, right? You can build the best system all you want, but you need to make sure that the users themselves are happy with the system and that they're able to use it. You can't make something too difficult and that a user is like, okay, well, I'm trying to initiate the the cameras, but I have no clue how to even turn it on because now it's a 10-step process. Whereas the actual target audience was more suited for a two-step process. So understand the user, that's why the user representatives are important. And then you have phase 6, and phase 6 is assess effectiveness. Think of this as such as like CMMI or capability maturity model, where you're actually monitoring and you're seeing how you're looking for continuous improvement, right? So you're saying, okay, is it effective? How am I doing? Do I need to go back and make some changes? Understand how effective that particular system is. So if you have a breach, okay, well, everything worked well, but understand that this camera needs to be placed elsewhere because we have a dead zone right here because this camera it doesn't do a full filter or whatnot, or we don't have control, or we don't have eyes on this particular area, and that's where individuals are able to come into our building. All right, so defining business mission needs. And so basically, these are various considerations for building location and how it should be built. You need to look at natural disasters. So what natural disasters will happen? Adjacent buildings, crime, riots, airport, highway. These are all items that you have to think about. Also got to think about power source, water source, emergency support, fire station, hospital. All of these items are crucial to setting up your physical environment. Right? I'm not going to say I have a new organization that we're going to set up in New Orleans, or we're going to set up right downtown. That would be ridiculously stupid, especially knowing the natural disasters that happen there, right? Crime. We're going to set up buildings off of Del Mar, the other side of Del Mar. Probably not the best idea because of crime. Riots. And I'm going to set up an area that is known for riots. Not the best idea. You have to think about all these items. You got to think about the will individuals try to see your organization as a target? If something does happen, is there power? Do you have stable power? And that's important, especially when you think about developing countries, right? If you travel to a number of these countries, say Dominican Republic, Gambia, Ghana, Nigeria, you'll notice that a number of these countries, the hotels have power source. So if you're saying, all right, I'm going to set up a business here, well, you need to understand how much power will you actually have. Is it the sustainable power? What is your water source? Especially if you're setting there's all types of stuff to think about. Fire station is important. You don't want to be too far away from a fire station. Additionally, you want to be in an area that has a dedicated fire station. Some of these cities have volunteer firefighters. So if something happens, you may have to wait. It may take a little bit longer for the firefighters to, come. All right, so plan and define physical security requirements. So do a critical path analysis for the site's location, construction impacts, and facility impacts to basically list all the elements of the physical security and how they interact with each other. So this is power, data, water, AC generators, storm drains, and sewer lines, and then basically understand what is critical for business functionality. So what do you need for the business to function, right? So the COOP is the continuity to operations plan. That's what the COOP is. So business continuity, COOP, continuing of operations. Then you have your disaster recovery goals. So you need to make sure your business continuity is aligned with your COOP and your disaster recovery goals. And we'll talk about this a little bit further. You need to conduct a business impact analysis, information sensitive classification. Now, this is what we've been talking about kind of throughout the course in terms of information sensitivity and classification. This deals with how do you actually categorize your information. So, whether it's unclassed, secret, top secret, confidential, or proprietary. So how do you classify your information? And then you have to consider different business laws, not business laws, but consider different laws and regulations. These are like building codes, fire codes. All those items are important because they differ from city to city, state to state, and county to county. For example, back in Huntsville, Alabama, in the city of Huntsville or even Madison, there are stricter codes for actually building. Well, in the city of Huntsville, definitely there's stricter codes for doing add-ins in addition to homes and stuff like that. Out in the county, you can pretty much do whatever you want. So if I wanted to build another garage, I may have to go through my HOA to actually build that. But if the HOA gives a go, I could pretty much do whatever I would like to my home in terms of additions, adding a new garage, and all that other stuff. So the same thing with the organization. There may be certain building regulations or codes that you must actually abide by. Same thing with fire codes as well. You may have to have another exit. You may have to make sure items are illuminated so people are actually going through the building, they know how to get to the exit and all that other stuff. And then building codes also affect what items or may affect the even type of structure that you actually, buy or put your organization in. So you have to look at those particular laws and regulations. It's very important. It can end up being costly later on. All right, in terms of facility location, again, this is, natural disasters. So, what natural disasters are known to happen. And you can pull natural disasters out through a number of different tools from the internet. You can just do a quick search and say, all right, well, let's see, I'm looking at this area here in St. Louis versus looking over in Alton, Illinois. Let me look at the natural disasters associated with both areas before I actually decide to buy. Then look at hazardous terrain. So some areas, there's excessive snow, rainfall, you get mudslides. Some areas, such as like Montgomery, Alabama, they were some of these home divisions were actually built over previous swamps and stuff. So, you need to understand what is all the items, all the physical items that are associated with your actual location. And then, of course, you have surrounding areas and external entities, local crime, riots, and of course, proximity to police, medical, and fire stations, and then also potential hazards from surrounding areas. Now, accessibility is important. You need road access. You need to worry about excessive traffic, and then proximity to airports, train stations, and highways is important, especially when you think about getting key people in and out, bringing in goods. Maybe your organization is doing something where you want to make sure you have quick access to the airport. We can have, maybe a direct trucking line from the airport to drop off, ship off goods to your actual location. And then visibility, building, marking, and signs. This depends on what type of organization you are. If you're doing something you're trying to be obscure about, then you don't really want building, markings, and signs. You just, of course, you're not really worried about visibility. Then also high or low population area. This is important at times because you can have someone that tries to social engineer the system. If you have tons of, you have a high population area, lots of traffic, individuals could, come in and pretend or pose as potential employees. Now, types of neighbors. So understanding what other organizations are nearby you, right? So if I'm a bank, I'm not going to set up a bank near a jail or maybe a rehab center or something like that, right? Or say I'm a children's center or I'm a battered woman center, I'm not going to set it up near a, near some type of criminal entity, right? So those are the things to think about in terms of location. Now, here in terms of terrain, basically it's talking about the distance from the fence boundary to the building, distance to the adjacent building or structure, and then also roadway to path or building. Now, all these items are important. Landscaping, shiny shrubs or trees, and the spiny shrubs are kind of important. So if you're in an area that may be, you're in a gated area, maybe you want these spiny shrubs, right? So these are extra deterrents from having someone actually enter your home. So now you have these spiny shrubs in front of the window. So no one just walks up to the window and, goes into the window. Now there's shrubs that can hurt them in the way. Still looks nice, but there's something there at least to block individuals from actually entering your home. Garage side or gravel traps. And then, of course, water, drainage pond, lake, or stream. So these are other items to think about as well in terms of landscaping. All right, so in terms of natural surveillance, you can use replacement of physical environment features, personal walkways, activity areas, ways to maximize visibility, open stairways. You got to make employees feel safe and intruders feel uncomfortable. And so that's really the goal of it. Now, you can over secure something, I'll say that, or you can make it where the employees feel a little, I wouldn't say that they feel uncomfortable, but you have to make sure at least your employees feel safe. So it's a balance act because employees need to feel like they're safe and they buy into this, and that intruders say, okay, well, I'm not going to try to do anything because, this is probably not the environment to do something like that. All right. Then in terms of territorial enforcement, basically physical designs that emphasize or extend a company's physical sphere of influence so legitimate users feel a sense of ownership of that space. So walls, fences, flags, basically you're stating that this is our organization, this is ours, please stay out. But as an employee, you're like, okay, as an employee, you say, okay, this is my banner of the company that I work at. They have these walls, so I know that when I go in there, I feel, I feel safe. It's a community, right? That's why it says create a dedicated sense of community. So everyone within those walls belongs there, right? And so that's something that you have to think about, and that's why the flags and all this other stuff is good, because individuals say, all right, I belong here. This is where I belong. So individuals that that are coming up, it's like, I don't belong here. I have nothing to do with the organization. So let me try to step away. Of course, there's still always going to be somebody that tries to enter no matter what. But at least for the majority, you've created that dedicated community. Individuals do understand that more like they don't belong. In terms of target hardening, building access controls, you have entry, exit points, windows and doors, interior partitions. These are walls, ceilings, and floors. You think about crawl space. Think about being able to hear through different walls and stuff like that. These noise cancellation items that you can use are white noise items, basically. So if you're talking about a particular topic, individuals can't hear outside the door. Like I said, different types of locks and intrusion detection that can be used. In terms of utilities, power sources, water sources and sewage, AC, heating, cooling, humidity control. This is important, especially for your server environments and stuff like that. And then, of course, for your fire controls, detection and mitigation, because someone could have an arsonist at your organization. All right, in terms of physical security policies and procedures, you need to have integration with your business continuity, COOP, and disaster recovery plans. I'm going to say DRP going forward. The disaster recovery plan is known as DRP. It's just that's what the acronym is. Then periodic inspection and reports. Now, the periodic inspection and reports is important because you can't just set a plan there and check once every 3 years. You need to do these inspections a number of times, depending upon the size of your organization and stuff like that. Awareness training is important, so individuals are aware of all these particular items that are in place. And then testing and drills need to, run live drills, right? This is why we run, back in high school, we ran fire drills so that students knew how to get out in case of a fire. Same thing after Columbine happened, a number of high schools started running drills so they know how to respond if there's a shooter or a bomb threat. Then you have the risk management process, basically assess and identify threats and threat agents. Risk mitigation, a plan for change and updating the baseline. And then also risk evaluation to verify and validate countermeasures. And so it's important. This can actually be covered in your risk management plan. So if you have an overall risk management plan, these items can be thrown in there, right? Because say if you're building a particular product, your potential customer will want to know, well, what risks are in place that someone just doesn't enter the building and just takes all the items that you're actually building, right? They just come and steal the plans. So something like this already addressed would actually fit into an actual program or project management plan. Now, security audits and assessments, basically review audit trails of entries and exits. So anytime someone enters and exit, you can actually audit those items. You can have it set up where it's a key card that gets individuals in and out over a particular pen. And then you want to perform assessments or walkthrough. Basically, it's a desktop exercise. And so what we'll do in terms of doing a walkthrough, we'll be using virtual worlds tonight to actually do kind of a walkthrough and kind of how to set up your own environment for running through a physical security setup. And so we'll do that tonight. And then also that deals with simulation. And then, of course, you have a full interrupt test. Now, you have security guards, and you're going to put these guys in place to make complex decisions. So checking credentials at entry points and at exit points as well. Ensuring company property doesn't leave the facility. So no one's actually just lifting desktops and hard drives and all other good stuff. And then ensuring and verifying that doors and windows are locked. So they're actually going through and making sure items are unlocked, because you can have someone on the inside unlocking doors and windows or moving the cameras so there's a blind spot so someone can actually enter. So watch for piggybacking. Piggybacking is when someone enters a particular building and then someone tries to enter behind that person. You have that happen quite a bit, and not intentional, but maybe someone forgot their badge at home, or they forgot in their car and it's raining and they don't want to go back out to their car, or you just have people who are just in a rush for a meeting. But you still got to watch for piggybacking, because not everyone is doing it unintentionally. Some people are doing it intentionally. And then the guard shouldn't be stationary. So they should be, you have someone at a post, and you can have a revolving guard that moves from post to post. And then you want to change it to routine at least every week, or at least every so many weeks, so that individuals do not get accustomed to their routine. And so for the person that's on the outside trying to, capture routine, they say, oh, well, this individual has moved from this point to this point. Okay, it's not the same routine. So I really have to rethink about my way of actually entering this particular organization. And here it says personnel is the most expensive countermeasure to reduce physical security risk. Also, your security guards are going to, depending type of organization, they may be armed, they may be trained appropriately in physical combat if that item or should arise. All right, so in terms of structured barriers, perimeter structure, walls and fencing, basically specifically gauge and fabrication specifications, specify height or need for a top guard. And so here's just kind of giving you some examples of galvanized chain link. And then here it's talking about the height and then kind of the associated height with the protection. And so this is kind of saying, okay, you have 1 meter to 3 to 4 feet, deters casual trespassers. But if you have 2/4 meter to 8 feet with the top guard, this deters determined intruder. And then of course the item in the middle, essentially just too high to climb easily. So these add additional thoughts in the head of, hey, I'm going to enter this building, but oh wow, there's a fence or there's a wall now, because trespasser may just be a couple kids spray painting, but then you may have somebody who really is wanting to actually get into the building. Well, now they're wondering, okay, well, we really can't climb this, so let's go somewhere else. All right, so in terms of barriers, you have gates, bollards, roadways, doors, windows, ventilation airways, manhole covers. And then you also have the Department of State and DOD anti-ram vehicle barrier certification criteria. This is the SD standard 0201. And it's pretty neat. So here you have the vehicle weight, 15,000 pounds, speed ratings, and then of course speed at impact. And then also you have the vehicle weight. And then also they have the associated penetration rating and then the penetration distance. So you have these items that kind of help you build upon, a structured barrier. And so there's a number of standards that already exist. And so that's why I say when you're building these security plans and you're thinking about the organization, there's a number of these particular items that already exist. Take what already exists, use that, and then modify that to build what you need for your organization, right? You don't necessarily have to start from scratch because there's a ton of information that's out there. You can say, all right, well, I need to put a building in this particular location. It's a, low crime area. These are the type of crime, this is the type of items that happen here. This is the type of traffic I have, and use all those to make a decision on how you're going to build this particular item. But the problem is these items can change, right? So, 20 years, that low crime area has now become a high crime area. And now you have to adapt for your current environment. So that's why it's important when you think about physical security, think about scalability as well. And think about if something does happen, how would you be able to change in that event? All right, in terms of facility construction, more about structured barriers. You have different classes. So you have a class 1, which is a residential gate inspection. Class 3 is a commercial. This is basically parking lot or garage. You have a class 3, which is industrial, limited access. This is like a warehouse facility or loading dock. And then you have a class 4, which is restricted access. Basically, you must have supervision by security personnel. And this would be like a prison or airport security area. So these are the type of structured barriers to think about. Basically, this is talking about, vehicular gates. This is the UL standard 325. So these are the 4 classes that are specified with facility construction. All right, so there's also other items to think about. So in terms of exterior inner walls, you have structural, sound, and Tempest. Now, Tempest deals with emission security. So Tempest is also found if you're doing the DoD, doing DICAP, whatever the new successor is. Tempest is important. It's actually a certified Tempest testing authority, and they actually look at cabling, any EMIs that are radiated and stuff like that. And so they will focus on Tempest. And so Tempest is really big in terms of electromagnetic stuff like that. electromagnetic emissions, EMI. Then windows, structural exposure to sunlight, size and height, ceiling, roof, and floor, basically the structural and access, and then structural, earthquake proofing, and then fire resistance. All right, so lighting is important as well, even though it seems like, okay, well, maybe it's not as big, but it's an important deterrent for intruders. And then, of course, it says it assists with other access control systems. Think about cameras, right? So you need lighting to make sure cameras are working. Maybe you have infrared cameras, maybe you don't. So you need to have the item lit so you can capture who these intruders or who these trespassers are on your property. So you have continuous lighting. Basically, this is fixed luminaries arranged to flood a given area continuously. You have trip lighting. Basically, this is activated if somebody walks or trips a particular area, then the area lights up. You have standby. This is similar to continuous lighting, except luminaries are not continuously lit. Emergency, basically, these are activated only in emergency events. Power failure, fire, maybe someone kicks in a door, maybe there's some type of emergency lighting or some type of lighting that comes up, but that's just emergency lighting. Then you have different types of lighting. You have glare protection lighting. This is for a particular area to deter intruder actions. And then, of course, you have a floodlight, and this basically is to light a large area. All right, so you have technical controls. You have entry access controls. You have turnstiles, and basically turnstiles are revolving doors that can be activated to lock and not allow unauthorized access to individuals to enter or leave a facility. And this helps prevent piggybacking. So say if you don't have a guard, turnstiles would be a great technical control to put in place, because now individuals go through a turnstile. Only one person can fit in there at a time. That's the expectation. One person can fit in there at a time. And so they go through, they get checked, and then that's it. And then the next person has to go through. Now, it may slow down individuals get into the building, but that would just, employees would be, I guess, inconvenienced, because now they have to make sure they're a little earlier to make sure they go through the turnstile. Then you have man traps. These are basically routing two people through stationary doorways. You have fail safe. These are door defaults being unlocked. And then you have fail secure, which means door defaults are being locked. So fail safe, everything's unlocked. Fail secure, everything's locked. That's it. All right, so in terms of locks, you have mechanical locks. These are key, combinational, magnetic locks. And then you have electronic locks. These are combination lock, proximity, RFID, badges, and biometric. And of course, the electronic locks are going to be a whole lot more expensive for an organization, but will offer that added security. So with mechanical locks, you're not going to get your strong authentication. Remember, something you have, something you know, something you are. However, electronic locks, especially biometric, you're going to get strong authentication. So now, at this door, you have strong authentication or a strong authenticator at this particular door. Of course, it's not going to be cheap. So what I did to my house back in Alabama, one of the things I did, I removed my mechanical locks, and I actually put a biometric lock on the door. So my mechanical lock is about maybe $15, max $15 for mechanical lock. But when I put my biometric lock on there, my biometric lock was about $300 per door. So you can see the price went up exponentially with that biometric lock. You have intrusion detection surveillance systems. So IDS is intrusion detection system. And these are items that detect access to a controlled area. So you have photoelectric, ultrasonic, microwave, passive infrared, pressure sensitive. And so these items understand, basically, they detect access to a particular area. You have your CCTVs, which is your closed circuit television. They detect the presence of an object, recognition of an object type, identification of object details. Now, there's different types of CCTVs that can be used, but these are kind of what these CCTVs should actually be doing. Now, these are different considerations when you think about CCTVs. You have charge coupled device, converts pixels into data signals. Cathode ray tube converts picture image to data signals. Field of view, basically, it captures the area that can be captured by the camera's lens. So the camera lens can capture maybe 20 feet. That's pretty much what's captured. Then you have depth of field, basically is the area between the nearest and farther points that appear to be in focus. So maybe up to 20 feet, it's in focus, and it still can capture items above that. but those items won't be focused, so it'll be blurry or something like that. And then you have to think about monochrome or a color camera. Now, there's different risks to power supply. So you have the blackout, which is basically complete loss of commercial power. You have the fault, which is momentary power outage. Then you have a brownout, which is the intentional reduction of voltage by a power company. You have sag and dip. This is a short period of low voltage. You're not getting the voltage as you actually need. If you look at a number of your different electronics, it'll say what actually voltage is needed. So take a look at that sometime. Then you have a surge. Basically, this is a certain rise. This can actually burn out electronic circuits. Important to understand that. Then you have an inrush current, and this is the initial surge of a current required by a load before it reaches normal operation. And then you have a transient, and this is just line noise or disturbance. It's superimposed on a supply circuit and can cause fluctuations in electrical power. Countermeasures for power supply risk. You have your UPS, your uninterrupted power supply. So you want to understand how many UPSs you need. You might need it in your server room, especially if you're, server room, UPS, any type of items that you still need to operate. Then you need your surge protector. This is, surge protector, circuit breaker, transformer. This is for like a brownout, sag, dip, surge, inrush current, and transient. And so, these are other items that you may need, and you need to understand how many of them that you can actually afford as an organization. Now you have risk of electronic discharge. This is basically when two non-conducting materials rub together. There's all types of stuff you can do for this, for electronic static discharge, grounding equipment. You can make sure that the employees themselves are grounded as well. These are like wrist straps, flooring, clothing, and footwear. Especially in engineering organizations, a lot of these organizations will take you through a short course so that you understand about ESD and the importance of it. You're not going to electrocute yourself, and you're not going to damage the equipment. Then, of course, you have flooring, seating, ionization of air, and then humidity control, appropriate marking of equipment, package facility. And so some examples they provide are data center, grounding of rack and floor, so common point of ground, raised floor tiles. Raised floor tiles is also used in terms of security. So not just in terms of ESD, but also for security as well. All right, different types of HVAC systems. So you have your upflow, basically force air above the floor. You have the downflow, force air below the floor, water and glycol. Then you have HVAC considerations. You have to think about your cubic feet per minute, humidity control, temperature control, air filters, positive air pressures, protected intake vents, alarms. The alarms are for leak detection and loss of power, temperature, humidity, fire, smoke detector. Now, a lot of times when you think about these items, you're like, okay, I've never thought about HVACs in terms of security, but they really are important when you think about the building as a whole. If you have questions, remember you can always answer. You can ask any question that you like. There's a Q&A section that's open, and so you have any questions, feel free to ask any questions. All right, so here you have you're talking about for cooling, plumbing, and sewage fire suppression. These are basically water supply outside the room. Think about your water source, the water usage, the volume of water, filtration, and environmental impact. The environmental impact has not always been there. This is something that's kind of new because, now we're trying to be more conscious about what's kind of going on and stuff like that. All right, so I did get one answer, and this is live. So this is live and available for the entire world to see. So it is a live class. However, once the class is done, it is archived. So later you can download it from the web, and I'll show you how to rip it from the web in class next week. But it is live. All right. And then, of course, you have water pump to maintain the pressure. So you need to make sure that there's a certain pressure in terms of the water moving through. So you need to make sure you have the appropriate water pump. All right, so different types of fire suppression. So here's your different, you have your different fire classes. You have your class A through K. So A deals with common combustibles, elements. You have ashes, paper, wood, cloth. And then suppression method, water, soda, acid. So I'm not going to go through this in depth, but on this particular slide, which is slide 48, it does go through all the different types of fires and then the associated suppression method. This is important because you don't want to have, the incorrect type of fire suppression item mechanism next to an item that it cannot even be used for. So make sure your items are where they need to be so that you can have everything matched against one another. And so here's just going into it a little bit more. We won't cover that in depth, but just know slide 49 just talks about it a little bit further. All right, so we'll just go through this real quick. Here's talking about dry pipe. Basically, there's no water standing in a pipe. The air is blown out and water is released. And then time to delay can allow the system to properly shut down. And so this is just a sprinkler system. It's a type of sprinkler system. Something to think about in terms of how your organization set up, in terms of what items are actually going to be from room to room. All right, so we are done with the presentation. And so the presentation portion is done. What we're going to do now is actually go through the Second Life. And so we're going to get Second Life set up. We're going to pull up Second Life. And so I sent out a email to go through what needs to be done through Second Life. And so you'll see that. So this next presentation is really short, really quick, and this will lead into our Second Life exercise. All right, so this presentation here was done a while ago, basically talking about online incident response training, virtual worlds as a cost-effective tool for homeland and cybersecurity. All right, so one of the neat things with Second Life in terms of training, what we looked at was actually using it to simulate real-world training. So in terms of incident response training and physical security, we can say, all right, well, we're looking at a certain map and location. We're going to map out various areas that may be, tons of crime or tons of incidents to respond to, and we're going to use that to actually build the technology or the building type that we actually need. And so here it just shows that a little bit better. You can kind of see how things are kind of broken out in this SL grid. And so that's what you see here. Also, you can use SL for identification of key targets. So you can, do these items virtually. So you can create your virtual sandbox. For those who are in the military, you may know that they have a term. It's called creating a sandbox. So it's like your play environment for the real environment. So you say, all right, this is my rally point. This is where we're going to meet up. This is our rally point. We're going to go through here. We're going to go through these particular bushes. But now you can do everything virtually in terms of training and stuff like that. So this right here just shows an example of identification of key targets. Here, in terms, we talk about, business continuity and disaster recovery planning. We can have a virtual map where we say, okay, well, we know it's raining here, it's sunny here, and we can move around this map and say, all right, well, let's take a look at setting up something here. So we can do a walkthrough and an overlay, a weather forecast overlay on a particular map and just do kind of a walkthrough. The other cool thing is in terms of interactive walkthroughs, imagine that you put everything on a particular smart device and you can do a walkthrough on the smart device, right? So you can map out an entire building or room and then put it on a smart device. You can do this also for like selling stuff, but you can also use it for individuals that are coming in, say it's a firefighter or policeman, and they need to understand how the actual building looks before they actually get there, rather than just looking at a plain 3D map. Now, this is a Second Life campsite mock-up, and it's pretty interesting because you can see the detail that's here. And this is a virtual campsite mock-up, and the level of detail is just simply amazing, how this can actually reflect what the real world version looks like. Now, in terms of equipment training, this is just an example. This is Northrop Grumman's Cutlass bomb disposal robot. To the right, you actually see the full-fledged bomb disposal robot. And here you see the Second Life, the virtual world or Second Life comparison, the simulation of the real world item. So at least here you can say, okay, well, this is how it's supposed to look. These are items it's supposed to do. You at least can do some limited prototyping and limited training on this virtual item rather than spending, lots of money creating, full-fledged mock-ups of the real device. So you can have someone learn controls and things of that particular nature. Now, I showed this the other day. This is the Moses item. This is done out of Maxwell Air Force Base, out of Air University. And basically, this is just an interrogation scenario where individuals can actually, play as actors and go through how an individual should be interrogated and stuff like that. So yet another physical security item that's taking place in the virtual world. Now, Open Simulator, this is, so Second Life, Open Simulator is the open source version of Second Life. So Open Simulator, you can actually run this and host this on your own server. You can make sure it's secure, especially if you're doing something like building plans or you're some type of police or security entity. You may want to have something like Open Simulator where you do this on your own environment, where you're not worried about people seeing what you're doing, what you're practicing and stuff like that. Of course, in Second Life, you can make islands private, but it's just best to take something like that offline and host that yourself. There's different types of viewers, and you've noticed that yourself. So those who've had issues with any of the viewers, you'll notice that some of the viewers may or may not work. Some are supported. Some may no longer be supported. Some of the viewers are used for HD. Some of the viewers are used for making movies. Some allow the ability to see all the objects individuals wear. So you can see actually the objects they're wearing and all that other good stuff. But for what we're doing, a object will be good. So the regular viewer will be okay. So it's no big deal. So the regular Second Life viewer will be okay. Now, 3D Studio Max is a great tool for those that are in like CAD and stuff like that. In terms of doing your physical security mock-ups, you can do those mock-ups using 3D Studio Max and a number of other tools that are available. But in terms of image quality and kind of the output, you can kind of see how amazing this thing looks. So you look here and you actually see, how the inside of the building looks. So it looks really, 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 really interesting. So you can see kind of how realistic it actually looks in terms of creating an actual mock-up. Now, Blender, I'll show this in class. I'll show this in class next week and give you an example of how Blender looks. But Blender is just another tool where you can actually create 3D simulations and stuff like that. Now, in terms of scenario planning, going to kind of walk through this. This is something that I did for an actual book chapter on national international security. So basically, you can decide what your target is, and that's what we'll be doing tonight, deciding what your target is, performing research on a target using Google or any other web or 3.20 tool, capture online maps or building architectures, and then render those items with a graphical application software. And then with that, we can prepare the mock-up scenarios. We can test run those mock-up scenarios, and then we can do a live run. So we'll be doing this actual scenario today. So this is the scenario we'll be doing. So we'll learn how to use Second Life, how to operate, how to perform kind of this analysis using the web, and then take these items from the web and actually use it to create a full-fledged, mock-up scenario where we can actually run through various activities. All right, I'm going to close that. So we are done with the actual live chat. What we're going to do now is we're going to go into Second Life. I gave you the name. The name is Engineer Fuzuku. So make sure you have your email and you check that. I also gave you the island that we'll actually be on, and I will meet you there in a little bit. So I do appreciate the 5/6 viewers I do have. This is archived, so I will post it for your fellow cohorts. So for those that were snowed in or without power today, that they can listen to it as well. In the meantime, I will see you in Second Life.